All right, good day to my Programmer Logic Controllers 2, Week 1. This is going to be a little crash course of what you're going to learn and what you did learn. So you want to take a look at this PowerPoint in this video prior to the lecture that's coming up. There's a lot going on, and so what I wanted to do was just kind of dive you into the lab first to get you used to the software, and then using this little reference here to kind of see what you're going to learn and then what you did learn, and then hopefully blending the two, it'll make sense. So we'll go over this in class where I'll do the welcome, go over the textbook, safety policy, all the stuff like that, and then I'm going to turn you loose on the lab. And we'll talk about the disclaimer here that there's a lot to learn here, and you're going to learn a lot, and it's going to be good, okay? And then I'll talk once again in class about, we'll go over the homework and the schedule, and I'll be signing this, and then, here we go, we'll get into the lab. And so the purpose of this little PowerPoint is just to kind of go over the configuration, because this is what you are going to do in the lab or / did in the lab, depending on, when you're watching this, okay? So the first thing we need to do is we're using RS Links. So RS Links is it's the bane of our existence. It's how we connect everything up here, and that is the little icon down right here. You can type RS Links and launch it, and then you can come here, communications, configure drivers. This is where we went in and set up our drivers when we were doing the Slick 500. I'm going to go ahead and delete this one. I don't want any drivers in here. I'm going to go ahead and set one up for you here in a second, but we are using RS Links. We are also using a Ethernet adapter, a USB to Ethernet adapter, and that we know that our controller is going to be on a static network. Our controllers are 192.168.1.xxx. The address scrolls across the controller, 192.168.1.xxx. Whatever that number is, that is the bridge in your controller that you are going to use. We use one controller, and we'll divide it to 2 or 3 people. We've got 5 of these, and I think this time, between 10 and 15 people in the class. So you might have 2 people on a controller, or you might have 3. You got to share a little bit, but we will use a static IP via the switch to USB to Ethernet adapter. I'm going to show you how to do it, but the instructions are in the lab, okay? And so the number here is 192.168.1 is our network. So the way to get there, whether you're using Windows 10 or 11, I can type network here and let me see if I can do it this way, network status, and then let's see what I got. I can go to change my adapter options here, and let's see what comes up. Okay, so this is my network. I got Bluetooth, Cisco. Here's my Ethernet. I'm not plugged in. You are plugged in. You'll have something here. And I got a Wi-Fi. You're on a desktop. You won't have that. So I'm going to go ahead to my USB port, and I'm going to plug in a USB to Ethernet adapter. I'm reaching for my port right now. I just put it in, give it a second, and there it is right here. And you got to remember that it says USB on it. So USB to Ethernet adapter is what we're using. This one right here says Intel on it. That is the motherboard on my computer, or the motherboard on your computer. And you don't want to be screwing with that. You want to be working with the USB to Ethernet adapter. So I come in here and I select it. Change the properties. Remember, it's TCP/IP4, which is right here. I double click that, and I'm going to use the following address, and I'm going to use 192.168.1, and then my last number here needs to be different than what your partners is, depending if you have 1 or 2 partners sharing the controller. It has to be different than that, and it has to be different than the controller, and it has to be different than any other device that we put on the network here. Over the course, we're going to have IP address conflicts because somebody didn't ask your partners what your number was, but I'm going to just make mine 25. So if I was 25, the controller can't be 25, the VFD can't be 25, the remote Ethernet can't be 20. Nobody can be 25 except me. And then if I come right here and I click this, it will populate my subnet. It will go over that a little bit, and I'll click OK. So at this point, I should have a NIC that is set up on this. Now, I don't have anything plugged in. I don't have a controller plugged in. So when I go to links and I try and set this up, it might not actually do what I want to do. But when I go to communications and I do configure drivers, and I want to add an Ethernet IP driver right there, add new, there it is, okay. And then if it's set up right, mine didn't catch it because I don't have anything to plug into, but it would be the USB to Ethernet adapter, and it would be it would say 192.168.1.25. You know, I would pick that, the one that has the IP address you just set. I don't have a controller plugged in, that's why it's not going to do it. And I would hit apply and OK. And then when you came to communications RSU, I'm not plugged into a controller, but underneath here, it would populate with your control logics processor. So this procedure is in the lab. And then I'm going to go right here. I'm just going to unplug this again because I don't have a controller plugged up into my computer right now. But that's how you're going to go, and you're going to set up your communications. Okay. So then coming back to here, that is our Ethernet setup. Good luck with that. We'll be doing a lot of it. Now, the next thing you want to do is you're going to go in and you're going to configure your unit in your I/O. So when you go into Studio 5000, I've launched it, and it's coming up here, the new project. I'm going to call mine Class Demo. We're using a 5570 controller. I'll hit Next. And remember, we're using version 28. The revision level of the hardware has to match the revision level of the software, and we happen to have 28. The lab said 24, but we're using 28. I had to flash those for Windows 11. And then the CPU is in slot 1, but you can put it wherever, but it has to be, we're in slot 1. So I'm going to hit finish here, and it is going to launch here. Just take a second here for it to launch. I can actually maybe pause. Okay, mine launched. It took a little while, but here we go. Now, this is Logic Design. This is the way it looks like, and you're going to get really good with this. Now, this looks a little bit like Siemens, where we have the tree over here, how we have the controller tree. And if you go to the main program right here, you can see that there'll be a main routine right here, and that is where you might program ladder logic. Like here's a contact, and oh, I had to add that wrong. Let's try that again. Here's a coil, here's a contact. And so I would be, programming away here on the main routine. Now, when I talk about I/O, we are going back to 260, where we had globally scoped tags and locally scoped tags. So if I go up to my controller tags right here, these are my globally scoped tags, okay? And I click on it, and there isn't any controller tags. And if I go to my main routine right here and I click on local tags, well, there's no local tags because I haven't made any tags yet. But we did that in Siemens, where we made 1 PB, 2 PB, 3 PB, and we called them I0.I0, I0.1, I0.2, whatever. It's similar to this, where you can create your tags locally, or you can create your tags globally. So now when I go to the global tags here, that's my I/O. My input modules, my output modules. There's really only one push button going to be wired into input 1. Okay. So now when I go and set my I/O configuration up, I can come down here and I can do, if I was online, I could do discover modules. If you downloaded this blank program and did discover modules, well then it's almost like the SLC 500 where it would add them, okay? But I'm not online, and we can add them manually. So if I come right here and do new module right here, I'm going to add an input module. So I want to go, 1756-IB16. There's a DC input module, all right? So I'm going to go ahead and create that. And the lab walks you all the way through this, all right? And I can call this DC inputs. And I don't know, it's probably in slot 0 on our controller. Remember, slot 1 is the CPU, so that's not giving us the option. Now, what's critical here is you got to go to change, and you want to disable the keying on this, because if you have an exact match, it has to be the exact module that's in there. And then when without discovering it, you're not going to know all the revision levels and all this kind of stuff. So I just disable the keying. I'm going to kind of create a generic program here that I can transfer between machines if I happen to sit someplace different or somebody does something. So there, I'm going to click OK and close this. Now look I'm still in my controller tags up here. Now look, all of a sudden, I've got some controller tags because I've got local input here, data. And this is going to you'll get used to drilling, way down in here. But, I've got all this data right here now for my local input module, okay? And so here's my monitoring tags. and here's my, if you double click right here, this will make this bigger. You can see, you know, what my data looks like in here for this input module. But I didn't have that before. As soon as I added an input or an output card, all of a sudden I've got some controller tags because they're global. Now I wanted to make a local tag, for example. I could take that data and I could go to edit tags. I could call this input 1, and it would be an alias for, and then I got to drill down here in the lab. We'll find it. Look, here's my globally scoped data again. That's what I just showed you in the controller tags. Here it was data. You'll get used to really drilling down. I could make this the 0. 1 right there. Did it take it? Yep, there it is right there. And all of a sudden I have input 1, which is the alias tag or the local tag, and it's located at this data point. It's an input, it's on data bit 0, okay? And then if I went to my ladder logic and I wanted to do this, I could just, you know, come here and guess what? I could use input 1 because that's my local tag. Or if you didn't want, you know, if you didn't want local tags, but that, you know, input 1, you could call that push, you know, your first push button or the emergency stop or something that's very descriptive. You know, you could come here and, oh, I keep picking the wrong thing. Let's just put that there. Oh gosh, that's crazy. Oh, that is because I keep hitting it. Sorry. All right, so if I come here, if I didn't want to use a local tag input 1, I could put a globally scoped tag right here, data, and then come here. I could just use the data point if I wanted to, but remember, there's no description here now. You're like, well, where's point 1? Well, you better know your machine really well, because there's no information here of where to find this. Where if this said motor starter 1 or Fanic robot 3 or something like that, well, you would know where you were going, you know, to find that. Okay, so that's kind of a quick run around through these tags here. Okay, so you're going to configure the I/O modules. We're going to initially do them just offline. You'll get better at discovering modules online. In the lab talks about how to go through and set up the I/O configuration, electronic keying. Remember, we are not doing exact match. We're going to disable the key. Later on, we'll do a little logic setup. For this lab, you're going to, and it's step by step. You'll be setting up the 5571. Remember, it's revision 28, even though the lab says 24. Our slot chassis is like a 10 slot. Our CPU's in a certain slot. So I just kind of showed you how to set up a 5571 in slot 0 with that 1756 IB16 in slot 2. I just showed you how to do that with disable keying, and you're going to do it in the lab, and you'll get good at it. Here's the controller organizer. I just went over that with you. That is showing here. It's kind of, it keeps the thing here about where your local tags are, what your main routine is. Later on, we'll get into doing subroutines. Here's my I/O down here. If you need to make some changes to the I/O down here, you just double click it, and it pulls up the setup that we had. That's what it looks like. You know, if you accidentally did not disable the keying, you can double click it here. You can go to change, and you can disable the keying or maybe the wrong revision, everything like that. Just by clicking on that down there, pulls up the I/O cards again. So you'll get really good at going through the organizer there, just like you did when you were doing Siemens. The memory layout. And so there's no fixed areas of memory. So 6500 wanted B3, T4, C5, R6. We don't have that. You just make the tag name and then you put it in there. There's no timers for T4 or anything like that. So for example, if I wanted to do a local tag and I wanted to call this timer 1, and my data type right here is, you can search it right here, or you can just start typing timer, and it will come up, and then I got a timer. So boom, I made a timer called timer 1. Notice it's not T4 or anything like that. And if I expand this, notice it automatically set up the done bit and the timer timing bit and the accumulation and the preset bits and everything like that. It's a predefined tag. Timer is in there. You'll be doing some timers here. And if I wanted to go my main routine, well, I could go to timer right here, and there's a TON right there. I could just drag it down. Boom, there's a timer. I could come right here. My the only timer data type I've got is the one that I just created. So that's the only option it's given me, and boom, I've got a timer in there. Okay. And you'll learn, another thing you'll learn to do, and I know I'm working fast, is that everything is contacts and coils. So this coil right here, maybe I did want it to be a timer. So you just double click that coil right there and type TON, and there's your timer. Okay, you want a FIFO, maybe you didn't want a timer, you put a FIFO in there, boom, and then there it is. Or an OTL, whatever. You will quickly be able to change those once you remember all the acronyms for timer on or whatever. Okay, so there's no fixed memory. You just create it and go. The tags, once again, we just did that. It's tag based, like the Siemens. You'll learn how to drill down into that data 0, 1, 2, 3, 4, 5, etc. You'll get good at it. But the address, this is the globally scoped or the controller tag that says your location. Is it local? Ours is on the rack, so it's local. We don't have any remote I/O or anything like that. It's an input module installed on the rack, just like we did with Siemens, just like we did with SLC 500. What slot is it in? 1, 2, 3, 4, 5, 7, 8, 9. What type is it? An input or output? And then what bit? Things like that. So that address right there is your base data, but often we're going to give it a name like input 1, PB1, whatever. And then the scope is, once again, is it program scope tag or is it a controller scoped tag? And right here, we made in our local tags right here, these tags right here, input 1, input 2. These are program scope tags. We're going to use this input 1 in this ladder logic right here. But remember, these aliases, input 1, do reference data that is controlled back up here in the controller tags. Now, if I came right here and I needed like a bit, and I came right here and I like, my favorite bit is, I don't know, holding bit 1. This is something that's totally fictional, right? Data type is going to be, once again, you can type here, you can just go Boolean, okay. And it's, I've got a holding bit 1 here. It's a fictional. It's a bit. Normally, you would think this would be, oh, that's a B3 if you were thinking, if you were thinking SLC 500. But yeah, there's no B3. You just make it up. There's my holding bit right there. It's a fictional bit that would, if I click this on, this would latch on and it would stay on. Notice in my controller tags, there's no holding bit 1 up here. This is for I/O. Cards that are installed or tags that you would want to use throughout the entire program. And here, this is my main routine. That's where my local tags would be. You'll get really good at doing the global tags. And then, this was a tag example. I just showed you that, having a program scoped versus a local tag. And your tag types here, the base tag is the data. That's hard to remember what that is. So hey man, let's just give it a name. Take that base tag data local 2 data 0, and then we can give it a name of fan motor. And then we know, oh, the fan motor's busted. Boom. Well, that's on bit 5. Okay, so that's exactly like Siemens. We were just using an alias, a name for that. And right here on mine, that's what I did. I said holding bit 1 or input 1. Input 1, we know we could go to the local module and start looking at the card in slot 1. And at the bit 0, we could see, the button came unwired. I don't know why it would come unwired. Or the wire got cut, or the button's not working. But we could look at right on the local tag to see it, right on the controller to see if it was working or not. And then just once again, our data types were Boolean, SINT, and then real. We'll be using a lot of different data types. And I just showed you that right here. If I make a holding bit, like just like once again, you're thinking like a B3, that's a Boolean. It's 0 or 1. Whereas this timer right here, well, if I have a preset, remember a preset is a number. It's not off or on, and therefore it needs a number. Okay, so when I go to my preset and let's see, let me make it, let's say 2000, that would be 2 seconds, okay? 2000 would be 2 seconds for my preset, okay? And the EN, the TT, and the DN is, well, yeah, is it done or not? So this is a Boolean. It's done or it's not. It's timing or it's not. It's enable or it's not. but the preset in accumulations is an actual number 2000, which is in binary, and we'll do a lot of binary. 2000 is 1111101000. Okay, and if I wanted to look at this, my radix is binary. Double click this. It is 1111101000. That's my timer preset in binary, but a lot of times we like to look at it as a decimal. 2000 timer preset of 2000, and then you're all set. And if I came back here, by the way, again, notice I changed it there and it went to 2000 here. I might change it here to 4000, boom, 4000, and I went back into my local tag. You can see if I click down here, monitor tags, it went to 4000. So either way, it's just a 4-second timer, because that's the way that works. So these are the data types. We'll be doing a lot with the data types, and you'll just be getting into them. Data descriptions, here's, if you want to read this, Boolean is 1 or 0. SINT has 8 bits. Int has 16 bits. A double word has 32 bits. And then a real is your 7.65. A lot more about data types later. You're just setting this up. So the structures we talk about, like a structured tag, I just showed you that when I entered that timer, it came in as predefined tags, like a counter. If you bring in a counter tag, it'll have the preset, the accumulation, the counter up, the counter down, the done bit, the overload, and the underflow. Okay, I put in a timer. The timer came right in with, let me close this up again. Oh, let me close that up. Let me expand this. I had my, it came in with my PRE, my ACC, my EN, my TT, and my DN. I didn't have to create these. It's a predefined tag. Same thing if you do a counter, edit tags. You want to make this called robot, hang on, we'll call this robot counter. And data type is counter. You can just start typing and it pulls it up. And sure enough, there it is right there, my preset, my accumulation, my counter down, my done bit, my overload, and my underflow. So it's predefined. So you don't need to create all those tags like that. Those are my predefined. You'll do some timers and counters, and we'll hit it hard next time. But this is from 260. You remember your timers had these values and your counters had these values, and you can review your 260 notes, or as we get using them, you'll be good with them. Module defined tags, I talked about this. These were the module defined or the local tags. When you put, or the globally scope tags, when you put in local one, your input, it puts it in there. So you're gonna have some module defined tags, which are going to be your IO modules, are the main ones that we're going to use. Automatically create IO modules to configure for the system. Yep. If you put in outputs and inputs, they all are globally scoped controller tags. You can make local tags out of that. User-defined tags, we're going to get into a little bit later. But basically, you can make up your own tag if you want. Call this tank, and inside of this tank, you can make your own tag that has integers and dints and reals and counters and timers. You can just box it all up into its own tag. I don't want to get too much into user-defined tags right now. But there you go. Creating tags. You're going to do this in the lab, or you did it in the lab. You can create tags in different ways. You can create tags as I've shown you. You can use a question mark and then make the tag from there. So let's say you wanted to come in your main program right here, and you wanted to put in my favorites, and I wanted to go right here. There's the question mark, and I could just go right here, and I could right click, and I could make the new tag, right here out of the ladder logic. Whereas before I went into parameters and local tags, and I made the tag here, and then I used it. If I go back to this, I can just right click and go new tag, and this might be called limit switch, and it's a local tag. No, yeah, it's a local tag. It's a base tag because it's on or off, and it's an alias for, or it's an alias tag, sorry. It's an alias for, here's my input module right here. That was my input module. Here's my data. We already used 012, so that would be my input there. And then I would create it here, and then boom, I've got a limit switch now on data 2. So somehow I've got an input on .0. Here was the one where I showed you where we didn't have any descriptions on it, so it might be confusing. But obviously on the second bit here, you're thinking limit switch. Okay, so that's another way to do them. You kind of create them here as you go. the lab will do it both ways. We'll either do it there or in the last part of the lab, you'll just create them all right here. You'll have all your tags ready so that you'll come here. You'll just pound in a bunch of ladder logic with question marks, and then you'll do the lab from there. Kind of program as you go. We talked about the tag name. Hopefully it's descriptive. It may be up to 120 characters in length. You can put some descriptions on. You put descriptions on there. 120. Sorry, in the tag name. 40 characters in length. Trying to be descriptive about what's going on. The new tag dialog box. That's where I did there. Right click new tag, and I just created it for you. I showed you. So like I said, when you prefer, you like to create tags as your programs. I usually create most of my tags first, and then I program. And as you're going, you might say, oh, I need another bit. Well, then you'll just come right here. I need another bit. You'll come right here, and you'll say, let me put this down here. Oh, I need a bit right here. And then so that's where, instead of coming into my local tags and making the bit, I'll just quickly make a bit right here, and I'll call this holding bit 2. Holding bit 2. It's just a boolean. It's not IO. It's not an alias for anything. I just click create. Already exists. Holding bit 2. Sorry. Yeah, I already had holding bit 1. All right. So then boom, I can make the tag right there. And guess what though? If I go to program local tags, holding bit 2 is there. Okay. Here's holding bit 1. So this is a way to monitor tags and to edit tags, either as you create them or after you've created them. You can do it all right here. And here's the monitor tags for all the tags that have been created one way or the other. Monitor and edit tags, I just showed you that, how you want to monitor and edit the tags, and whether you want to look, sometimes you want to look at the radix a little bit different. Here's my holding bit as a decimal. Well, if I look at it as a binary, well, it's 0 or 1. It's not, that's not very special right there. It's great to look at it as a decimal 0, 1. But if you wanted to look at a dent, you might want to look at the binary 0, 1, 1, 1, 0, 1, 0, 1, 1. It might be useful to you. We'll get into that. So the trainer setup, you can have multiple processors on here. We have the 5561s, but they're in there. We're not really going to be using them. You can have multiple processors. The processors do not have to be in slot 0 like they were on the slug. I think ours is going to be in slot 1. We're using the 56L71. Remember, it is version, can I do this? Version 28, because I had to do them. You can swap the cards here. It's not a bad idea to turn the controller off before you swap them. SIC 500, you can't. And you want to take a look and identify your IO, push button, selector lights, whatever, left to right, up to down. We'll go over this. Once you mess with the trainer a little bit, you'll understand what I'm talking about here. Just to be sure that the light, when you turn the light on, the light that you thought was going to go on goes on. And when you push the button, it goes on. And so I showed you setting up a processor input card. It says input cards are backwards. It doesn't matter in the processor. You can go in, or on the rack. You can have input, processor, output, input card. You could mix and match the cards however you want. Just be sure the IO cards are identified and you're putting it right in there. So this is the IB16D. We'll break this all down next lecture. That's what we're using in our input card properties. Remember, we are disabling the keying. Okay, we are disabling the keying. And then our output card, we're using OB16D to turn on the outputs. Once again, we are going to disable the keying on it. Okay. So then it says lab. So once again, you're either going to watch this, hopefully, before you do the lab, just so you can kind of jam through it. The lab shouldn't be too bad. Or you're watching this after the lab. So, or maybe both. Do both. Watch it before and after the lab. So, oh yeah, I get it. This makes sense. So that on Friday we're gonna crash course it again on this, and there'll be a quiz on it. But we're gonna move right along on the next lecture and get into safety relays. So all this basic operating system for logics here, how to navigate controller tags, local tags in the main routine, and set up IO. You're going to need to be pretty good at this, after the very first lab. And so that's why I'm giving you this little lecture video. So see you soon for the lab. That's what I got for you.